Welcome to another Win-Win Math video. Today's video, find all ordered pairs x and y that satisfies both x squared minus xy equals 6 and xy plus y squared equals 4. We'll first take the two equations and let's add them up to get x squared plus y squared is equal to 10. Then let's look at the first equation and let's isolate xy. So we'll add xy to both sides and subtract 6 to both sides. Then with this new equation, we'll square both sides so that we can have this y squared right here. Now back to the x squared plus y squared equals 10. We're going to subtract x squared both sides to get y squared equals 10 minus x squared. So that we can then substitute into this equation to get x squared minus 6 quantity squared is equal to x squared times the quantity 10 minus x squared. We'll expand both sides. Left side will expand to x to the fourth minus 12x squared plus 36, whereas the right hand side expands to 10x squared minus x to the fourth. Let's subtract 10x squared to both sides and add x to the fourth both sides to yield 2x to the fourth minus 22x squared plus 36 is equal to 0. We'll notice everything is divisible by 2, so we'll divide by 2 to get x to the fourth minus 11x squared plus 18 is equal to 0. Then we'll notice that there's an x to the fourth and x to the square, so this is a hidden quadratic. This looks very similar if you let u is equal to x squared. Then this looks very similar to u squared minus 11u plus 18, which factors down to u minus 9 times u minus 2. So x to the fourth minus 11x squared plus 18 factors down to x squared minus 9 times x squared minus 2. This whole thing is equal to 0. So we'll use the zero product property to get x squared minus 9 is equal to 0 and x squared minus 2 equals 0. We'll solve each of them and we get x squared equals 9 and x squared equals 2. So we have x squared. We just need x now and y squared and y. So let's clean this all up, make it look nice, and then let's solve them. Now that we know x squared is equal to 9, let's use the y squared equals 10 minus x squared to solve for x and y. So we'll substitute x squared equals 9 into this equation, and we get y squared equals to 10 minus 9, or y squared equals 1. And then let's solve both of them for x and y. And for x squared equals 9, we get x equals plus or minus 3, and y squared equals 1, we get y is equal to plus or minus 1. We'll use both of these, and here's our 4 solutions. And we want to make sure that these 4 solutions are valid. So let's start with the negative 3, comma negative 1. We'll substitute in each of these equations. So let's start with the x squared minus xy equals to 6. We'll substitute it in, and we'll notice we get 9 minus 3, which in fact is equal to 6. So this is true. But it's not enough to check just one. You also need to check the other one, just in case it doesn't satisfy both equations. So we'll test xy plus y squared equals 4 as well. Substitute in, and we find out that 3 plus 1 is in fact equals to 4. Therefore, negative 3, comma negative 1 is a solution to this equations, or set of equations. What about negative 3, comma positive 1? So we'll test this. We'll substitute in to the x squared minus xy equals 6. Substitute in, simplify, we get 9 plus 3 is equal to 6, which is not true. So from this, we can say that negative 3, comma positive 1 does not work. There's no need to check the other ones since we know that one of them doesn't work. But just in case, we can substitute in anyway, simplify it, and it turns out that it doesn't work. So we have negative 3, negative 1, but not negative 3, positive 1. Now let's check positive 3, comma negative 1. We'll substitute in the first equation, x squared minus xy equals 6. Substitute in, and we find that 9 plus 3 is not equal to 6, so this is not true. Therefore, 3, comma negative 1 does not work. There's no need to check the second one since this doesn't work, but we'll check it anyway, and we'll substitute in, and find out we get negative 3 plus 1, which is not equal to 4. So, checked off. But what about positive 3, comma positive 1? We'll substitute both equations, simplify. We notice that this is true, and when we substitute in the second equation, we notice that this is also true. Therefore, positive 3, positive 1 is a solution. So we have negative 3, comma negative 1, and positive 3, comma positive 1 as our 2 solutions so far. We also need to solve x squared is equal to 2. So substituting to the y squared equals 10 minus x squared, we get y squared equals 10 minus 2, or y squared is equal to 8. Then we'll solve x, we get x equals plus or minus root 2. Solve for y, we get y equals plus or minus root 8, or y is equal to plus or minus 2 root 2. Using the combination between both of these x and y's, we'll get negative root 2, comma, negative 2 root 2, negative root 2, positive 2 root 2, positive root 2, comma, negative 2 root 2, and positive root 2, comma, positive 2 root 2. Last but not least, we need to check our work. So let's test the negative root 2, comma, negative 2 root 2. We'll substitute in the first equation, and then we'll simplify. Turns out it does not true. So we know this does not work. We can substitute in the second equation, and again, we'll find out it doesn't work. Next, we can try the negative root 2, comma, positive 2 root 2. Substitute it in, find out that it's true on both equations. So we found that negative root 2, comma, 2 root 2 does work. Now let's check the positive root 2, comma, negative 2 root 2. So if we check this, substitute in both equations, turns out it will be true for the first equation and also true for the second equation. So we know positive root 2, comma, negative 2 root 2 is the solution. And then lastly, we'll check the positive root 2, comma, positive 2 root 2, and it turns out that it fails in both of them. So our two solutions here will be negative root 2, comma, 2 root 2, and positive root 2, comma, negative 2 root 2. Now let's put it all in one spot so we can look nice. And so if we put all four solutions together, here are the four solutions that will satisfy both equations. If you know another method, feel free to comment in the comments below. And again, if this video helped, give it a like, subscribe for more, click on the video on screen to keep learning. Thank you.